This is 5.5, writing equations of parallel and perpendicular lines. I know that you guys really understand what perpendicular and parallel mean, but now you're going to be writing the equation of the line for parallel and perpendicular lines. The definition of perpendicular lines, you guys know they intersect each other at a right angle. Parallel lines never intersect each other. The vocab term that I have skipped is converse. You don't really need to know it, but it's a statement that you can kind of flip around and it's still true. Let me say that again. It's a statement in which, where you take your kind of evidence and the conclusion that you've made and you flip that around and it's still true. When we get to the examples, you'll see exactly what that is, but you do not need to know what that is. Now, parallel lines. You know that parallel lines have the same slope. So if two lines have the same slope, then they are parallel. The converse of that, switch those two facts. So if I look and I know that two things have the same slope, I can say that they are parallel. That also means that if they are parallel, I can assume they have the same slope. So you can kind of flip those two facts back and forth. So if I want to write an equation of a line that passes through this point, 2, 4, and is parallel to line y equals 4x plus 1, if it has to be parallel, then that means the slope has to be the same. So in my equation, no matter what, if it's parallel, it has to have a slope of 4 because that's what was given in my equation. So my m is set at 4. And they gave me an ordered pair. They gave me a value of x and y, 2 and 4, and told me the slope had to be 4 for it to be parallel. I can finish my equation by solving for b, and I get -4 for my b. So my equation that is parallel to that line going through that point is y equals 4x minus 4. So now they're not going to tell you what the slope should be. You should know because they've told you it is parallel. Perpendicular lines have a very different connection. Perpendicular lines have negative reciprocal slopes. And if it has a negative reciprocal slope, it's perpendicular. If it's perpendicular, it's a negative reciprocal. Negative means that the sign gets switched. Reciprocal means that the slope that is the fraction, so like if we had a fraction 1/3, the negative reciprocal would be negative, flip those numbers, 3/1. If we had the fraction -2/5, the negative reciprocal would be positive 5/2. If we had just 4 as our slope, the negative reciprocal for 4 would be -1/4. So if we're looking at perpendicular lines, you're looking for that connection of a negative reciprocal. Now, if we need to determine which lines are parallel or perpendicular, that means I need to know the slopes of every single line. And the easiest way to know the slope of every single line is to make sure they're in slope-intercept form. Line B is already in slope-intercept form, so I know the slope of that one is 4. Line A, I have to rework though. So let's get line A to be in slope-intercept form. Subtract 12x on both sides. Divide both sides by -3. And y equals 4x minus 1. So if it's y equals 4x minus 1, the slope of line A is 4. Notice that that is the exact same slope as line B. Line C, I need to get the y by itself. Line C, if I get it into slope-intercept form, I'm looking at -1/4 x plus 2. And that means it has a slope of -1/4. So each one of those I put in slope-intercept form. Y equals -1/4 x plus 2. And then from there, slope-intercept form, I can identify all of my slopes. So my slope for line A was 4, slope for line B is 4, and slope for line C is -1/4. because A and B have the exact same slope, it means that line A and line B are parallel. On your homework, I'd like to see you write it like this. A is parallel to B. That's the symbol for parallel. Now, line C has a slope of -1/4. That's the reciprocal, that's the negative reciprocal of 4. So it's perpendicular to both A and B, because C is a negative reciprocal to A, so you can write A is perpendicular to C, and that is the symbol for perpendicular. It's an upside down capital T. And that B is also perpendicular to C. On your homework, I would need to see these three slopes and your conclusions about which ones are parallel and perpendicular. So if I am looking to write an equation that is parallel, I'm looking for the same slope of -3, but using those values for my ordered pair. I've got to finish my equation in slope-intercept form. I guess you could do point-slope form because it's not specifically asking you for one, but this is easy enough. And here you go. Determining which lines are parallel or perpendicular, remember they need to be in slope-intercept form. That really is the same equation. I don't know what's going on. So the slope here is -4. The slope here is -4. I forgot my negative on that first one, didn't I? And the slope here is +1/4. That means A is parallel to B, but C, because it has the negative reciprocal, A is perpendicular to C, and B is perpendicular to C. In example 3, we're trying to decide if the two lines are perpendicular. Well, if they are perpendicular, their slopes are negative reciprocals. That means I need to know the slopes. Let's find them. So let's divide everything by 6. 5, 6x plus, and now this part doesn't matter. You can leave it as 8, 6. The y-intercept in these types of problems don't matter. All we care about is the slope. And if the slope of the first one is positive 5, 6, to be the negative reciprocal, I'm looking for -6/5 here in in line B. So y equals, well, 12 over -10. 12 over -10, yeah, that would be -6/5. So, yes, these lines are perpendicular. And I can prove that because I have them both in slope-intercept form. Writing an equation of a line that goes through this point and is perpendicular to this equation, that means if this slope is 1/3, I need an equation that has a slope of the negative reciprocal, which is -3, going through that point. So the given equation has a slope of 1/3. Because the slope of perpendicular lines are negative reciprocal, the slope of the perpendicular line through this point has to be -3. And let's plug it into our slope-intercept form. My slope is -3, my x is -3, and my y is 4. So my b is -5. So my equation is -3x minus 5. And that will be perpendicular to the given equation, and we'll go through that ordered pair, -3, 4. Determining whether a line A goes through those 2 points, going through those 2 points, is perpendicular to the thing going through those points. Remember, we just need slope. I don't need a full equation to compare these. I just need the slope. So line A, the slope would be 4 minus 3 over 3 minus 1. So the slope for line A is 1/2. The slope for line B, using those two ordered pairs, -5 minus -3, 2 minus 1, -2 over 1. Are those negative reciprocals? Yes. Got a little excited about my E there. Yes, these are perpendicular because my slopes are negative reciprocals. Kind of the same checkpoint here. I want to pass through this point, but I want to be perpendicular. That means the slope I'm looking for isn't 5, but it's the negative reciprocal to that. So let's use my ordered pair to find my missing y-intercept. Oh, this isn't going to be pretty, is it? Then let's not do it this way. Let's write an equation in point-slope form. I have a point and I have a slope. Let's just write it in that form. Y plus 2 equals negative 1/5 x minus 4. I would take this answer as well. It didn't tell me specifically what form to write the equation in. And right now it's late and I know you're tired. Write it in point-slope form. It's fine. So in this example, it's a story problem. It's asking you the path of a golf ball bouncing off a curved wall on a miniature golf course is shown in a coordinate plane. Lines A and B of the path appear to be perpendicular. Are they? Don't tell me that yes, they are, because they do look it. They gave you the equations of the line. Guess what you need to do? Find the slopes. If those two lines are perpendicular, the slopes will be negative reciprocals. And in this case, yes, they will, because the slope of line A is 2/3. The slope of line B is negative 3/2. So you could do that work to prove it. And here is the homework for 5.5.